Welcome to AlphaNumericTricks. In this video, we are going to see some of the basic definitions under the topic representation of a function. And that we are going to see what is a vertical line test. That is how you can check whether the given curve is a graph or not using vertical line, and how you what is the condition for absolute value function, and when you say that a function is piecewise defined, and what is the condition for even and odd functions, and when you say that a function is decreasing and increasing. These are all the definitions we are going to see now. This is the Unit 1 Differential Calculus topic, and this comes under Engineering Mathematics 1 Anna University syllabus. Now we are going to see what is a vertical line test. In last video also we have the same topic. Under that we have problems, and we have seen that problems under domain and range. The link is available in the description box. If you want, please have a look on it. Now we will see what is a vertical line test. That is, to check whether the given curve is a graph or not, we have to use the vertical line test. For that, we have to consider the curve in the xy plane. You have to consider any curve in the xy plane. This is the xy plane. You have to consider any curve in the xy plane. Under that, you have to draw a vertical line which touches the curve at a point. Okay, at one or 2 points, whatever the points may be, and you have to draw a vertical line which touches the curve at a point. Okay, so look at this vertical line and the curve here. This is meets R touches the curve at only one point a comma b. That is, x is equal to a is the line touches the curve at only one point a comma b. So we can say that this is the graph. That is, a curve in the xy plane is a graph of some function f of x if and only if no vertical line intersects the curve more than once, meaning the vertical line does not intersect the curve at 2 or more points. It should touches the curve at only one point. So in this figure, the vertical line x is equal to a touches the curve at only one point. That's why we can say that this is a graph. So vertical line x is equal to a intersects the curve only one point a comma b. And also we can define, that is, we can see a function also. That is, function value is defined by f of a is equal to b. That is, the x is equal to a is the input, and we get the output as y is equal to b. That's why we can write f of a is equal to b. Here a is always known as your input and b is always known as your output under the function f. Okay, so for only one input you can get only one output. That's why it is a function, and also it is a graph. Okay, hence it is a graph of a function. Okay, now we will see another example. Consider this graph, or consider this curve. This is xy plane, and in this figure here the curve is given like this. Okay, here the curve is given like this, and then here you have to draw a line, vertical line, x is equal to a, which touches the curve. Okay, so here in this curve, suppose the curve the curve lies here, then we get only one point, but the curve, a single curve is given here. Suppose it moves along this curve. Here it moves along this curve, and when we come to this point, and here and this point and this point, the curve moves from this point to this point. Here you have 2 points, it touches at 2 points. Here the curve touches at 2 points. Here also the curve touches at 2 points. Okay, that is the line x is equal to e that meets the intersects the curve at 2 points. The line x is equal to a intersects the curve at 2 points. Here also you have it touches at 2 points, like that. So it is not a graph, because the graph condition is that x is equal to a meets the curve at or intersects the curve at only one point, but here it touches the curve at 2 points. So a comma c and a comma b, that is, a is the input and b is the output. Here a is the input and c is the output. So vertical line x is equal to a intersects the curve at 2 points a comma b and a comma c, and this curve is not a graph of a function y is equal to f of x. Otherwise we can say that f of a is equal to b, and here f of a is equal to c. Okay, f of a is equal to b here and f of a is equal to c here, which is impossible because f cannot assign two different values to a. Okay, here in the same a, that is what is a function? Exactly one input, you should have exactly only one output. That is the definition of a function. So okay, we can say that a function then, okay, it mixes at 2 points, then we can't say that a function also, so it is not a graph. Okay, this is the way we have to conclude using vertical line test. Next some more examples we will see. Consider this parabola x is equal to y square minus 2. Here in this parabola, this is the parabola y square minus 2 and touches the point minus 2 comma 0. And here when you draw a vertical line here, when you draw a vertical line anywhere else, here the vertical line intersects the parabola at 2 points here also. And suppose you draw the line here, it meets 2 points. Here you draw the line, it meets 2 points. So it is not a graph. Okay, now consider this. When you reverse the values of x and y, then you get the above the x-axis only you can get. This is the parabola y is equal to root of x plus 2 and this parabola lies above the x-axis. So this is the parabola, and when you draw a vertical line here, it meets the parabola at only 1 point. So this curve is an example of graph. So consider the another curve, and this is also y is equal to minus root of x plus 2. Here when you draw, this is the curve and this is the parabola that is below the x-axis. The parabola lies below the x-axis. Y is equal to minus root of x plus 2. Here when you draw a vertical line x is equal to a, it meets the parabola at only 1 point, a single point. So we can say that it is a graph. So this is not a graph, and this curve, this figure is a graph, and this parabola is also a graph. Because if we reverse the rules of x and y in this parabola, we get the y is a function of x, that is a graph of the function, we can say that. Now we will see what is absolute value function. What is absolute value function? The absolute value are magnitude of a real number x is defined by modulus of x is equal to x if x greater than or equal to 0, is equal to minus x if x less than 0. So here when you substituting x is a positive, what is the meaning of x greater than or equal to 0? X always takes a positive value, 0, 1, 2, 3, like that it can take. So here you can get a positive value. Suppose what is the meaning of x less than 0? 0 is not included here. So minus 1, minus 2, minus 3, you have to take it. When you substituting x is equal to minus 1, minus of minus 1, it becomes plus 1. X is equal to minus 2, you are substituting. Minus of minus 2, it becomes plus 2. So all the points it is get a positive value. This is the meaning of absolute value. So that is the interpretation or the effect or the purpose of taking absolute value of a number is to strip away the minus sign. That is, you have to remove the minus sign if the number is negative, and to leave the number as it is or unchanged if it is a positive number or non-negative number. This is the absolute value function. For example, when you're taking modulus of 5 is equal to, what is the modulus of 5? 5 is a positive number. When you're taking a modulus, it's a 5. 5 alone you have to write it. And here minus 4 by 7 you have to take a modulus. So modulus of, whenever you are taking a modulus of a negative number, you have to write the positive number as your answer. 4 by 7 is your answer, and the modulus of 0 is equal to 0. Now we will see one example. Sketch the absolute value function f of x is equal to modulus of x. Given f of x is equal to modulus of x, then you have to define x modulus x is equal to x if x greater than or equal to 0, and is equal to minus x if x less than 0. Now we have to plot this in the graph or figure. X axis and then y axis. Now this is the line y is equal to x, and this is the line y is equal to minus x. What is the line y is equal? This is the, here you have to, this is the line y is a 0, and this is the line y is equal to x, and here you have this a point minus x. Y is equal to minus x is the line here. So y is equal to x is the line, and y is equal to minus x is the line, and combining these two lines you get y is equal to modulus of x. This is the graph of the absolute value function f of x is equal to modulus of x, and and the line, that is the graph of f, coincides with the line y is equal to x with the right hand side of y-axis, and the line and coincides with the line y is equal to minus x with the left hand side of y-axis. Okay, this is the absolute value function graph. Now, next we will see what is piecewise defined functions. What is the definition of piecewise defined functions? A function is often described by different rules over different subintervals of its own domain. Such a function is said to be piecewise defined or multi-case functions. That is, so for example, you consider this absolute value function. Here, modulus of x is equal to x if x greater than or equal to 0, and is equal to minus x if x less than 0. In this interval, that is 0 to infinity, the function is defined x alone, and if x takes negative values, it is defined as minus x. So it takes, that is, we have different rules for different subintervals. We have different rules for different subintervals. Rules meaning you have the function, different functions in different intervals, you have a different functions. That is the rule here. Okay, a function is a rule. We already know that function. What is a function? Function is some rule. So rule are that rule of a rule is defined. Okay, so that's why some rules are different intervals, you have a different rules. Okay, that's why it is a piecewise defined function. Another example, signum or sine function. Here signum of x is equal to 1 if x greater than 0. Suppose x takes positive values, it takes 1, the function takes 1, and x is equal to 0, the function is 0, and if x takes negative values, that is x less than 0, and the function takes the value minus 1. This is the example of piecewise defined functions, because it takes different rules over different intervals. Okay, so different subintervals, we have a different rules we have to follow, 1, 0, minus 1, like that. We have different rules we have to follow. That's why it is an example of piecewise defined functions. Consider the function defined by f of x is equal to 1 minus x if x less than or equal to minus 1 is equal to x squared if x greater than or equal to minus 1. For all x less than or equal to minus 1, we have the minus 1 is included here. So we have x is equal to minus 1, minus 2, minus 3. That is minus 1, maximum value of x taken here is minus 1. Below that, that is before minus 1 we have to consider, just for example we consider two numbers, minus 1, minus 2, minus 3. Now we have to check what about y is equal to 1 minus x. Then when x takes the values minus 1, minus 2, minus 3, what is 1 minus x we are going to see now. Put x is equal to minus 3. What is x is equal to minus 3 here? Minus of minus, it becomes plus, so 1 plus 3 is 4. When you substituting x is equal to minus 2 here, minus of minus 2, it becomes plus 2, so 1 plus 2 is 3. When you substituting x is equal to minus 1, minus of minus 1, it becomes plus 1, so 1 plus 1 is equal to 2. So this is the points we obtain when x takes less than or equal to minus 1. What happens if x greater than or equal to minus 1? The function is changed here. Okay, y is equal to x squared in that case. So we are taking some numbers. When you are taking x is equal to greater than or equal to also included here. So we have to take greater than or equal to minus 1, we consider minus 1, 0, 1, 2, 3. Some points we are considering. Not here to take the points, we are not following any rule. Just we are taking some 4 or 5 points. That's all, to draw a figure. That's why we are taking this. Okay. When x is equal to minus 1, what about y value? Minus 1 the whole square is 1. When x is equal to 0, y is equal to 0. When x is equal to 1, 1 square, y is equal to 1. When x is equal to 2, y is equal to 2 square. What is 2 square? 4. Okay. When x is equal to 3, 3 square. Y is equal to 3 square. So which is equal to 9. So these are the points we obtain. So the combined graph of f is as follows. We have to draw the graph using these 2 points. Okay. So here we have this x-axis and y-axis we have, and 0 is the point here, and we plot the points minus 3, 4. X is equal to minus 3 and y is equal to 4. This is the point minus 3, 4 and minus 2, 3. That is the point minus 2 and 3. This is the point. And minus 1 comma 2 here. Minus 1 and the point 2 here is this is the point 2 and minus 1 comma x is minus 1 and y is 2. So these are the points, coordinate points we have, and y is equal to 1 minus x is a straight line. This is the straight line we are having, and next we have to use this points to draw the graph. Okay, x is equal to y is equal to x squared is a parabola, so we plot the points and draw the this minus 1 comma 1. What is the point? This is the minus 1 comma plus 1. X is equal to minus 1, y is equal to 1. This is the point minus 1 comma 1, and this is the point 0 comma 0. We have to plot it, and next point is 1 comma 1. Here is the point 1 comma 1. We have to plot it, and 2 comma 4. X is equal to 2 and y is equal to 4. We have to plot it like that. We have to plot, and this is a parabola we obtained it. Here, after drawing or joining the lines, okay, join the points, you get this is a parabola and this is a straight line. So after drawing the graph, we can say that here there is a discontinuity in the points x is equal to 0. Okay, sorry, x is equal to minus 1, that is a discontinuity. So notice that the point minus 1 comma 1 of y is equal to x squared is not included. Okay, and there is a discontinuity between the graph for all x less than or equal to minus 1 in the line y is equal to 1 minus x, and the graph for all x greater than or equal to minus 1. Okay, so there is a discontinuity in the look at the graph. There is no joining here, so here the point is missing. So this is the discontinuity of the discontinuity occur here, okay, between the graph of these two terms. Okay, and this is the some example of piecewise defined functions. Just we are drawing a graph and then we check it out, we explain what is that. Okay, now we will see what is symmetry. Symmetry is even and odd function. We can say that symmetry is even function. We see first what is the condition for even function. When f of minus x is equal to f of x for every x in its domain, then we can say that the function f is even function. For example, consider the graph of the equation y is equal to x squared. What is y is equal to x squared? It is a parabola. Okay, y is equal to x squared is a parabola, and this is the graph of the parabola. The graph is a parabola, and then f of x, suppose we substituting here. Here we have in both the sides it is symmetry about, that is the equal distance from y-axis. This curve is equidistant from the 0 to x. Here x and minus x. When we draw the line here, it is equidistant from the origin. Okay, that's why it is an even function. We can say that it is symmetry about the y-axis. So f of when you say f of x is equal to x squared, and when you substituting x is equal to minus x here, minus x the whole square, minus x the whole square is equal to x squared, which is again equal to f of x. So f of minus x is equal to f of x. We can say that from this we can conclude that it is an even function, that is it is symmetry about the y-axis. Now we will see what is odd function. Odd function is a function satisfies f of minus x is equal to a minus f of x for every x in its domain. Then we say that the function is an odd function. That is, when you say that a function is an odd function is f of minus x is equal to minus f of x for every x, then we say that a function f is an odd function. Now we will see this under the example. Consider the graph of the equation y is equal to x cube. Here, this is the graph of the equation y is equal to x cube is the graph, x-axis, y-axis, and here we have y is equal to x cube is the graph, and here this is symmetry about the origin. That is, from both the sides or from origin, it is even the equal distance. It have equidistance. Here f of x is from this distance to this distance is your f of x, and from this point to this point is your minus f of x. So this is our equidistance. So from this we can say that odd function is symmetry about the origin. Okay. Now we check it out. F of x is equal to x cube, and replace x by minus x. F of minus x is equal to minus x the whole cube, which is equal to minus x cube. So f of minus x is equal to minus f of x. From this we can say that the given function is an odd function, and it is symmetry about the origin. Okay, because it is from the origin, it is a equal distance from the origin, whereas an even function is symmetry about the y-axis, because it both the that is from y-axis, it have equal distances there. Okay, that's why odd function is symmetry about the origin and even function is symmetry about the y-axis. That you should remember. Next we will see some one example of neither odd nor even function. What is neither odd nor even? That is, a function is we can't say that a given function is odd function or even function. Both that is not, we can say either an even function or an odd function. That type of function is called neither odd nor even. That is, we can't conclude this function is an even function or this function is an odd function, like that. So such type of functions is called neither odd nor even. Consider the equation y is equal to x plus x square. Here f of x is equal to x plus x square, and substitute x is equal to minus x here. So here a minus x plus x is replaced by minus x, or minus x the whole squared, which is equal to minus x plus x squared. Here we does not say that this is f of x. Okay, so f of x is x plus x squared, so this is not equal to f of x, and is also that is not equal to minus f of x also. What is minus f of x? You have minus of x plus x squared as should be present, but it is not like that. So f of minus x is not equal to minus f of x. So this function is y is equal to x plus x squared is neither odd nor even function. Okay. Now we will say what is increasing and decreasing function. Consider this graph, okay, or consider this figure. In this, look at this curve. From the point A comma B, it rises. Okay, it rises. The curve rises from A to B, and B to C it falls, and C to D it again rises. So from that we can say that the curve is increasing in the point A to B and decreasing from the points B to C, and again increasing from C to D. So from this we can say that this is an increasing function, increasing and decreasing and increasing. Consider the 2 points between A and B, that is x1, x2. We consider 2 points x1 and x2 between A and B. A and these 2 points A and B, and we have to make the condition that x1 is less than x2. And when you substituting this x1 in the curve y is equal to f of x, we get f of x1, and when you substituting x is equal to x2 here, you get y is equal to f of x2. So this is the line y is equal to f of x2. So from this we can define the decreasing function and the increasing function. Function f is increasing in the interval I if or all x1 x2 belong to that interval. I is the interval, then f of x1 less than or equal to f of x2 when x1 less than x2. When x1 less than x2, then if f of x1 is also less than or equal to f of x2, then we say that the function f is increasing. Suppose the function f is, when you say that the function is strictly increasing, that in the interval I for all x1 x2 belong to I is f of x1 less than f of x2. Just that is, if it is not equal, if it is less than or equal to is not present, that is only we are considering f of x1 less than f of x2. When x1 less than x2, then we say that a function is strictly increasing. If f of x1 less than or equal to f of x2, then we say that a function is increasing function. Next we will say what is decreasing function or strictly decreasing function in the interval I and okay, so when you say that a function has a decreasing function in the interval I, suppose you are taking x1 x2 which belong to that interval I, means if f of x1 greater than or equal to f of x2, when you are finding the value, that is you are substituting x1 and x2 points here, and then after simplifying this you get the value f of x1 is greater than or equal to f of x2, then we can say that it is a decreasing function. Suppose you are substituting the points x1 x2 in the given function y is equal to f of x, and then suppose you get the value f of x1 just greater than f of x2, then we say that it is a strictly decreasing function. So generally speaking, increasing the increasing function is f of x1 less than or equal to f of x2 when x1 less than x2, and decreasing is f of x1 greater than or equal to f of x2 when x1 less than x2. Okay, that you should remember. That's it for this video. If you have any doubts in this, please provide in the comment section. Thanks for watching. Keep watching our YouTube channel AlphaNumericTricks for more videos. Thank you.